Hello, and thank you for attending today's webinar. We will begin the presentation in approximately 1 minute. Hello, and welcome to our webinar, where we will learn how ShopRunner processes a terabyte of data a day to recommend the right products. My name is Chaitanya Hazare. I am an AI ML specialist solutions architect for Amazon Web Services, and I'll be your host and moderator for today's presentation. When you joined today's webinar, you selected to join by either phone call or your computer audio. If for any reason you would like to change your audio selection, you can do so by accessing your audio pane in the control panel. From this control panel, you will also have the opportunity to submit questions to today's presenters by typing your questions into the questions panel. We will collect the questions and address as many as we can during the Q&A session at the end of today's presentation. Also, at the end of today's event is a brief survey. Please stay connected until the end of the broadcast and submit your feedback as your opinions count. Lastly, the PowerPoint presentation will be available through SlideShare along with a recording of the webinar on YouTube via an email that will be sent 2 to 3 days after the conclusion of this event. So please keep an eye out for the follow-up email sent to the address that you have provided. Let's take a brief look at the outline of our broadcast today. We will start with the story of AI as seen from within an organization where most of machine learning takes place than anywhere else. Then we will transition to our Amazon Partner Network competency partners, Databricks. And finally, we will hear from our guest of the hour, ShopRunner, and delve into the technical details of deploying a recommender engine in production. Please remember, please post your questions in the chat box throughout this presentation as we will review questions at the end of today's event. Along with me today, we have Brian Durking, who is a Senior Director of Partner Marketing at Databricks. Databricks are the original creators of Apache Spark. They provide an unified analytics platform to help in accelerating innovation of their customers by unifying data science, engineering, and business. And our guest of honor today is Hannah Torrance. She is a data scientist at ShopRunner. ShopRunner is literally Amazon Prime for everyone else. Their 6 million members get free 2-day shipping, returns, and deals across a growing network of 140 plus retailers. Some of the famous names, such as Hugo Boss, Kate Spade, and Jimmy Choo, are amongst these 140 plus supported retailers. Now, let me take this opportunity and set the stage for our deep dive. Customers and partners choose AWS over other providers because it has a lot more functionality, the largest and most proven vibrant community of customers and partners, the most proven operational and security expertise, and the business is innovating at a faster clip, especially in the areas such as machine learning and artificial intelligence, Internet of Things, and serverless computing. Machine learning at Amazon has been an active area of investment and research for the past 20 years. We have innovated, improved, and published original work in the area of machine learning for the past 2 decades, be it in the area of fulfillments and logistics, like in the case of our warehouses, using Amazon Robotics to streamline package creation, or be it search and discovery in Amazon Retail, or be it topic modeling in lengthy tomes, making content more accessible, or be it upcoming Amazon drone delivery system, Prime Air, which is a fully operational trial operating near Cambridge in United Kingdom. or be it amazing natural language processing capabilities of Amazon Alexa, or be it Amazon Go, a brand new retail store concept that is operated across the US. Amazon has been an innovator in the field of computer vision, forecasting, search and recommendations, natural language processing, autonomous drones, and applications in retail, amongst other areas. While machine learning has been around for 50 years, the cloud is enabling it to be applied at scale. In 2019, IDC estimates that 40% of all digital transformation initiatives will be supported by AI. What is our mission at AWS? Our mission at AWS is by the way of deliberate osmosis, we want to enable our partners, our customers. We want to take our rich experience with machine learning across Amazon and put it in the hands of all organizations, every developer, data scientist, and researcher. And how exactly do we do this? We are uniquely customer focused. We start with the customer need and work backwards. 90% of our AWS roadmap is built directly from customer feedback. We are unmatched in the breadth of ML services we offer to our customers today. We believe customer choice and flexibility are incredibly important. We support all popular frameworks and interfaces to give you choice and flexibility. We also have the deepest set of security and encryption features with broadest accreditations. And our approach to R&D is fundamentally different and unique. Our scientists are embedded within our product and engineering teams, and we invent and simplify on behalf of the customers. As a result, more machine learning happens on AWS than anywhere else. Why? Because we have the broadest and deepest set of capabilities. We see machine learning stack as having three key layers. ML framework, that is the bottom layer for the machine learning practitioners, researchers, and developers. This includes infrastructure. AWS offers broad array of compute options for training and inference with powerful GPU-based instances, compute and memory optimized instances, and even FPGAs. Then we have ML services. Amazon SageMaker removes the heavy lifting, complexity, and guesswork from each step of the machine learning process. SageMaker makes model building and training easier by providing pre-built development notebooks, popular machine learning algorithms optimized for petabyte datasets, and automatic model tuning, enabling developers to build, train, and deploy models in a single click. Finally, we have the machine learning services layer, which are ready-made for all developers, no machine learning skills required. They cover the areas of vision, speech, language, chatbots, forecasting, and recommendations. All this is powered by the highest performing infrastructure for your business. Let's talk about a few geeky stats. Our P3 instances provide up to 14 times better performance than previous generation Amazon EC2 GPU compute instances. The new Amazon EC2 P3DN instance has 4 times the networking bandwidth and twice the GPU memory of the largest P3 instance. P3DN is ideal for large-scale distributed training. No one else has anything close. Now, zooming out and switching gears. Recommender systems, the topic of today, are everywhere. They influence the world experience and the choices you make. Apart from being omnipresent, they are also a favorite topic of mine, and I can geek out on it for like hours together. Recommendations drive about 30% of traffic to Amazon.com. Given the amount of traffic Amazon.com receives, it's actually a very significant number. Recommendation engines deal with solving various machine learning problems, how to encode real-world data into vector form, how to represent various features of an object, how to then find similarities between objects. These are some of the things that Hannah is going to go into details in her presentation. ShopRunner's recommendation system is built on top of Databricks and hosted on AWS. Let me talk briefly about Databricks and our Amazon Partner Network Competency Partners. AWS Competency is our global partner program designed to promote and highlight our top AWS partners based on their overall specialization in a key AWS solution, workload, and vertical areas. Our goal is to be the most customer-obsessed partner program by providing our AWS customers with top vetted and validated partner solutions that can help customers take advantage of AWS products and services. AWS competency partners go through rigorous technical assessment and verification of their expertise specific to each AWS competency. Databricks is one of the few partners that hold multiple AWS partner network competencies. Databricks is a part of Databricks, apart from holding machine learning competency, also have big data competency, public sector competency, and healthcare and life sciences competency. I would like to now welcome Brian from Databricks to take us on a brief tour of the unified analytics platform hosted on AWS.
Great, thank you, Chaitanya. Great job. Hello, everybody, and thank you so much for joining us today. So a couple of things that I wanted to do. I just wanted to talk a little bit about who Databricks is so that as Hannah goes through her presentation, you have basically a framework to understand the company and what we're doing. As Chaitanya mentioned, our founders are the original creators of Apache Spark. Apache Spark is known as the top analytics and data preparation engine in the world. Used by all sorts of organizations to be able to prepare and then data and then run machine learning and analytics on top of it. Our goal is to really accelerate innovation by unifying data science, data engineering, and business, because when we started out, we really saw that data science and trying to get the data together for data science was very separate. So we'll talk a little bit more about that. We do this on our unified analytics platform, which was originally created on AWS and continues to run on AWS today. Besides, being the creators of Spark, we've also created Delta Lake and MLflow. I'll talk a little bit more about what those innovations are and how we've now made those open source as well. But we have over 2,000 global companies who are using our platform across big data machine learning lifecycle. As we look at this image, we see first off that Databricks on the Unified Analytics Platform integrates with a number of AWS services. We have a few selected ones over here on the left. This is an exhaustive list, but you see things like Amazon SageMaker, you see Kinesis for being able to do streaming data, Redshift, S3, so a number of different services that we integrate with in terms of data sources and then processes for being able to run machine learning. In the box in the middle, you can see the Databricks runtime, again, based on Apache Spark. But then also we know that data scientists like to run many different machine learning frameworks, and to be able to look at those differences and be able to choose what is the right, framework or library for the work I'm trying to do. So on top of Spark, we also offer TensorFlow, XGBoost, PyTorch, Scikit-learn, and a number of others. As part of the Databricks runtime. So very simply, you start up a Databricks cluster and you select if you want those machine learning libraries loaded, and then you're up and ready to roll. So that's a great way to be able to bring in many different machine learning frameworks. On top of that, we have the Databricks workspace with our collaborative notebooks. And this is really, the key thing that we've built on top of Databricks besides, the runtime engine. Because this allows data scientists and data engineers to collaborate seamlessly in one flow. They can go back and forth between their favorite languages. So a data scientist can be writing in Scala, and a data engineer can be writing in Scala, and a data scientist can be writing in R or Python, and just flow seamlessly back and forth. They can leave each other comments, et cetera. And I think the main thing that happens there is you go from an orientation of, as a data scientist, I need a new data set. I'm going to send an email, or maybe I'm going to, put up a Jira ticket or something, and then I wait a couple of weeks. By having folks working in the notebook together, it really speeds and accelerates that innovation. And that's where I see a lot of customers come to us and say, I bought Databricks because of the increased speed and the performance of Databricks. But really the eye opener was when we saw our data scientists and data engineers working together in the way that's accelerated innovation for their company, and it's a way bigger impact than they'd ever anticipated. So that's a little bit about that. Moving on to the next slide here. I think the thing that really it comes back to for us is we noticed very early in this process that writing machine learning code was only part of the process. And in this case, you can see, it's about 10% of the process. I mean, it's really about getting the data together and all the other pieces that go around a machine learning practice, including things like monitoring and deployment, et cetera. All of these are the challenges that every organization runs into trying to create a machine learning practice. And I think, what's beautiful about what ShopRunner has done is they've solved these problems to the point where they're able to run this on a fairly automated basis. So the data comes in each day, they're able to incorporate that, they're able to even take feedback on the models and bring that in. And I think that that's where, a lot of companies are still aspiring to be able to have that kind of an automation. And so that's what we're really excited, for Hannah to talk a little bit about how they got there. So just, recapping a little bit about Apache Spark, this is the de facto unified analytics engine. This was, originally what we created when we saw this problem. This actually goes all the way back to the Netflix contest about 10 years ago. Was really kind of the dawning of Spark when a couple of our founders were part of that contest and were trying to solve the problem. They found the biggest problem was they couldn't get the data to the machine learning libraries and algorithms, and so they looked at this and thought, well, there's a great way to be able to bring this all together, and that was the dawning of Apache Spark, and that's what's really made it the basis for so much analytics that goes on these days. So it's really, this unification that we were talking about in terms of bringing the data together and the machine learning that makes all the difference. And so for us, being able to look at data lakes, streams, NoSQL data sources, data warehouses, bring that all together with the machine learning, as we talked about, as well as the notebooks that do this process, but then also bringing in the different machine learning frameworks and everything here, and then even allowing you to use tools like RStudio. If you have, if you use RStudio as a favorite IDE, having that integrated and everything. And then what you get on the result side is, these machine learning outcomes. And so if you look down the right-hand side here, you can see a couple of different examples, recommendation and personalization engines, which, Hannah will talk about in depth. And I think what's interesting about that too is I've seen recommendation engines used in so many different ways. So even if you're not in the retail industry and you're looking to serve customers, I've seen folks using them in government for being able to enable people to choose different kinds of benefits. I've even seen companies use this for internal usages. So I saw, again, a benefit selection by a company where employees needed help in choosing what was the best benefits package for them. And so you could ask, 4 or 5 questions, figure out the predictor variables, and then go ahead and make a recommendation. So recommendation engines are super powerful and can be used in so many different ways for organizations. Other examples here, risk, fraud, and intrusion detection, Customer 360, inventory asset optimization, genomics, where Regeneron, we're solving liver disease together in terms of being able to identify key genomic causes. Inventory assessment, I mentioned, predictive maintenance is another example, and there I've seen folks using interesting algorithms like a market basket analysis, which is typically, when somebody chooses an item, another item, might get recommended along with it, kind of a hybrid version of a recommendation engine. But I've seen people using that for maintenance, where a particular part goes out, and there usually are other parts associated with that part going out. So when your water pump goes out, or when your belt goes out, you might also need to look at your water pump to make sure the bearings are working properly, or perhaps that's the reason that the hose went out ahead of time. So very interesting in terms of how these algorithms can be used in terms of different kinds of use cases in different industries. So I mentioned, besides Spark, one of our newer innovations was Delta Lake, and this is something that we introduced about a year ago, and then we made it open source just in the past 2 months here. It's open format. It provides data reliability and quality. It's compatible with the Spark APIs. It essentially sits on top of a data lake, and it standardizes the data inside of the data lake and enhances it and optimizes it. Provides ACID transactions. So when you go to write a data set, if the data doesn't get completely written, the data gets repealed back rather than having fragments of data out there. So it keeps your data lake cleaner and therefore higher performance. And it also provides the ability to do time travel. So I can go back and look at my data set at some point in the future and say, what was my data set on this exact moment at this day? And that's super helpful anytime I want to be able to go back and recreate one of my experiments, or if I'm getting audited or any of those types of things. And so we see customers, with large corpus of data, in some cases, 10 petabytes of data that they're running against, and 150 terabytes of daily data coming in. And these customers find they can only do about 2 days worth of data using their old systems to be able to do analysis, which was great, except for when you got to a Monday, right? If I've only got 2 days of data and it's Saturday, Sunday, and all of a sudden today's Monday, I'm probably going to have very different results. And so everything seems like an outlier all of a sudden. And so now using Delta Lake, they're able to look at 2 years worth of data, which provides for much more effective results and can enable them to make much better choices in terms of, in this case, it's intrusion detection, being able to identify intruders. So that's an example. And then, MLflow, let me go back one here. I just wanted to talk a little bit more about MLflow. Let's see if I can get back one slide. My keyboard doesn't seem to be doing it. There we go. Thank you. So MLflow actually came out of our work with data scientists, where we would talk to data scientists about their process. And one of the things that they mentioned was, I go through the step of data prep and everything, and then I go and I build a model and I run a bunch of different experiments. And in these cases, the experiments might be using slightly different versions of the data set. They might be using different machine learning frameworks, as we saw. They might be, having different tweaks in terms of the actual model that I'm building. And so when we talked to a lot of data scientists and asked them, well, how do you track that? Many of them kind of scratched their heads and said sheepishly, well, I use a spreadsheet for that, which, there's no shame in that, but obviously it wasn't as easy as it could be and as automated as it could be. And so that was really kind of the calling card for MLflow, where we saw this need for something to manage the life cycle of machine learning. So MLflow allows you to manage the data prep, the building process of the model, and the deployment of the model allows you to see all the different experiments that you're doing, be able to track those, be able to recreate those on any system, and then be able to deploy those models as packages, and to be able to also convey then, if your production team is going to put it into production, which version of each library you ran it, for instance, so you're able to get exactly the same capabilities. And MLflow is one of the key points in our integration with Amazon SageMaker. So that's exactly where we're able to build these models and then use SageMaker for deployment using the MLflow integration. Okay, so just again to recap the Databricks Unified Analytics platform, all these innovations are packaged into the Unified Analytics platform. Apache Spark, Delta Lake, MLflow, plus the additional machine learning runtimes. We extend that for being able to make it easy for folks to get the data in and be able to run analytics directly off of their data lake using Delta Lake. We provide the runtime for use for data scientists and data engineers so that they can collaborate, and then also so that they can put that data into production. You can use MLflow for being able to make sure that you get that proper stuff into production. And then, the other thing I didn't really talk about a whole lot, but a lot of this is automated in terms of being able to spin up and spin down clusters. And so that whole process really makes it a lot easier and allows data scientists and data engineers to focus much more on the jobs that they do best, without having to think about, now I need to spin up a bigger cluster. This is going to be a big job. Much of that is automated inside of Databricks, which is great. And then for being able to run that in production, you can simply schedule those production jobs, and that allows you to really be able to pull it all together. So you get an end-to-end ML workflow with Databricks Unified Analytics on AWS. One last thing I'll leave you with quickly, if this is intriguing for you, we have 3 virtual 2-hour training sessions using Databricks on AWS, getting started with Apache Spark, data engineering and streaming analytics, and machine learning. You can get these on demand. You can sign up now with this bit.ly /training AWS. Remember that URL is case sensitive, and hopefully you'll be able to go and take part in that and enjoy some of the free training that we have to offer. But most importantly, at this point, I want to hand it off to Hannah, who's going to take us through the ShopRunner story. Hannah, please take it away.
Thanks, Brian. Hi, everyone. I am going to be talking today about how we at ShopRunner have used data and machine learning to improve the shopping experience for our customers. So to start us off, let's talk a little bit about what ShopRunner does. So we like to describe ourselves as the Amazon Prime for everyone else. We work with a wide array of retail partners, from high-end fashion to sports gear to household goods. You can see a sample of partners here on this slide. And we work with these partners to offer benefits like free 2-day shipping and free returns to our network of users across this network of partners. Despite the name of our company, we don't actually handle any of the delivery or logistics. Our retail partners handle that kind of logistical process. We're really fundamentally a tech and data company. So in exchange for these benefits that are offered to our customers, we bring a bunch of benefits to our retail partners as part of being a member of our network. So we offer benefits like new customers from across the ShopRunner network, increased conversion rates and average order values, and then a growing set of kind of technology features that we offer our partners to help them better engage with their customers. And we can do this because we have a really full, complete picture of customers across this network that any one retail partner only has a really small window into. But we have a JavaScript integration as part of our integration with a new partner that lives on these partner websites and lets us see the browsing patterns of our customers across the network. So we collect terabytes of data each day. This includes really granular kind of product level browsing data and purchase data across this network. And then our retailers share product catalog feeds with us. So we get things like prices and inventories, product images, descriptions for around 10 million different products. So we have this really rich picture of our users through the browsing and purchase data, through all of this interaction data, and a really rich understanding of the catalog of products from our partners. And so between these two data sources, we can use our understanding of the data and our data science capabilities to better personalize our member experience in our own ShopRunner interactions with them, and to power products for our retail partners that help improve these customer relationships and experiences across the board. So I'm going to talk a little bit about what this data process looks like. So we ingest data from a whole bunch of different places. So we have, as I mentioned, we have product feeds from retailers. We have order and shipment feeds. So these tell us things our retail partners share with us when people purchase stuff and when orders get shipped and canceled and all of those good things. And then we have the page view events data from browsing. So all of the what products you look at different retailers across the web, across our partner network. And then this is, as you can imagine, quite the ETL adventure, because we have all of this from over 140 different retailers, which means that there's a lot of kind of integration challenges here. And then we need to support a wide variety of access patterns. So we need to manage the process of moving this data through our system. We need to support reporting dashboards and ad hoc questions for our analytics team and to support the variety of partner relationships. And then we want to be able to build models. So I'm a data scientist. The data science team is really interested in using this data to build predictive models that can help kind of power tools to better support our relationship with our customers and our relationship with our retail partners. So to dive a little bit more deeply into what we do on the data science team in particular, our goal overall is really to take these rich data sets and learn the patterns that can help connect our users with the products that they'll love, and to be able to do this at scale. So we tackle problems across a really wide array of kind of traditional machine learning segments. So we focus a lot around personalization. So how can we surface retailers and brands that our members will really love based on what we know about what they've loved so far? How can we recommend the right products at the right time? And then what can we learn about our products in order to do this better? Can we use computer vision or natural language processing from our product information to better understand the set of products we have available to people? And then how can we take all of these things that we learn about our data and our users and use them to support these interactions, whether that's in our customer mobile app, browser extension, our website and like email interactions with our members, or through tools that we offer to our retail partners that live on their websites and power their interactions with customers. So this is like an example of some of the tools that we use in order to do all of this. Our core language is Python. We are mostly a Python house. We work with PySpark extensively on Databricks. We have our data engineering team uses some Scala Spark on Databricks as well, but the data science team is largely Python. These Spark tools let us scale this data, which is vastly important, because as much as I love scikit-learn and all of our favorite Python modeling tools, that gets really challenging when you're working with really large-scale data. PyTorch powers a lot of our growing deep learning stack. And then we use Snowflake as a data warehouse. So this is where a lot of our data lives that we then use and clean and model on top of. And then tools like Docker and Flask allow us to easily deploy endpoints to integrate with the rest of the company infrastructure. So this is a really key asset in our kind of data science workflow, is the ability to quickly deploy small endpoints that can serve these results. And then you can go and talk with the engineers on a product team and have a really simple conversation about here's how you integrate with this. Here's how we get these models that we're building and these results that we're getting actually into products that our users can see. About another kind of key benefit of how this workflow works quickly and smoothly is the ability to quickly test out new approaches and figure out what the right way to store all of this is, right? So we have a bunch of data, we have a bunch of models, there's a lot of complicated infrastructure. Brian pointed out kind of how all of that infrastructure around the machine learning code is a lot of what happens and a lot of what needs to happen and a lot of what can go wrong. So one of the key benefits of working on AWS is the ease of spinning up different options and testing things out. So one way that we use this a lot is using different data stores. So we use a wide array of different data stores on AWS, from DynamoDB to using different RDS instances. In particular, the S3 object storage, and in particular, its really tight integration with Databricks, is super useful to us and a thing that we use all the time. Having a really easy kind of backend for storing data quickly and easily from Spark, and kind of to have that communication be really smooth, is super important for quick testing and optimization. It's really easy in long Spark jobs as you're kind of figuring out how stuff works to run a really long thing and then have something go wrong and not know where it happened. So being able to checkpoint things and save things into S3 is super useful. We use AWS Batch for scheduling our non-Spark workflows. So we have some jobs that are in particular deep learning GPU intensive, and we use Batch to kind of have a smooth workflow. Brian mentioned that we do a lot of kind of making all of this automatic and smooth flows. And Batch is a great way to do that for programs that run in Docker containers. And then we use GPU instances for training computer vision and natural language processing models. So this is an area we've been investing a lot in over the last year or so that has some really exciting opportunities. On the Databricks side, moving over to Databricks had huge implications for our kind of Spark workflows. The ability to have an AWS account that runs our Databricks, where we can have really both controlled and easy to manage access that lets us try and experiment with new things very easily. Effortless sharing and backups of notebooks is hugely important. You can go and look at your notebooks anytime and comment on them and share them with others without needing to spin up clusters just to read the comments or whatnot. The ability to leverage spot instances and auto-scaling for Spark clusters is a great way to easily save money on these large data jobs. And then quick and easy onboarding. So the ability to have somebody new start who does not have experience running clusters and managing Spark themselves, they don't need to worry too much about this. You can go into Databricks and a quick tutorial on how we like to organize our notebooks and what are good default cluster settings and all of that, and somebody's up and running, which is much easier than needing to kind of manage all of that ourselves. So between having the ability to do this experimentation up front and easily change the size of your cluster or spin up two clusters with slightly different settings and test out how they work is hugely beneficial. On the other side, once you have a thing that's working well and you want to productionalize it, figuring out what that means is a lot of the battle, right? On getting a new model into production, whatever that, like defining what exactly that means and how to make this repeatable and trustable and a thing that you have faith is going to work well. Databricks jobs let you schedule a notebook to run at a certain time, at a certain cadence, and offer alerts and kind of custom clusters that can get assigned to each job, which make these production level jobs super easy. So you can see we've got here on the left a list of a bunch of different jobs that run on our infrastructure and Slack alerts and a channel where you can kind of have the jobs post when they finish and tell you how it went. And it's a good way to keep an eye on jobs that run regularly. The way that we like to set this up is to package our code, our modeling code, our like data processing and modeling code into shared Python libraries, and then install them in Databricks as a shared library that you can then attach to an interactive cluster to try something out, or attach to a job to run in production. One of the kind of pain points that we had along the way in doing this was that once you have a lot of jobs and you have libraries that are attached to many different jobs, it becomes challenging to go through when you update your job and manually swap out the version of the library that you're using. We wanted to be able to do this from kind of CI/CD tools. So we want to take advantage of the infrastructure that our company has set up to do things like run unit tests and verify all the things you want to verify before pushing a new version of a library into production. But then we also wanted to be able to automate okay, this library is now in production, I want to go and update all of those jobs to use this new library. So we wrote a tool called Apparate that handles this for us, where you can pass, it's a little command line tool that takes an egg or a jar, either Python or Scala, and uploads it to Databricks and goes, and according to settings that you can configure, goes and updates all of the jobs you want it to update and to swap out the versions. If this sounds like a thing that's useful to you, we open sourced this package and it's available here. The GitHub link is below. It's been a huge benefit to us in our kind of production workflows to have this all be automated and not a thing that we need to worry about day to day. Cool. So now I'm going to talk through some specific products that we've built. So I've talked kind of in general about our workflow and about the types of problems we want to tackle. And now we're going to talk about some specific products that we've built. So looking at product recommendations, and in particular, looking at a similar products approach. So there's many different things that you can do with recommendations. There are many different ways you can interpret that goal to recommend products. But the first place that we started was, let's say we have a product that we know somebody likes, and we want to offer them similar products. And we're going to start off doing this with a collaborative filtering approach. So this is your basic people who liked this product also liked this other product. So you can see here that we have a setup with people on the left and products along the top. And my check mark here indicates that that person interacted with that product. So if we look at this example outlined in black, we have these products that this product was interacted with by these two people. And so if we go look at this product in green over here, the same people interacted with this product as interacted with this product. That suggests that those products are likely similar in that the same people are likely interested in them. So if somebody new, who we don't know anything else about, comes and interacts with this product, this dress, they're likely to also like this tank top. This suit, on the other hand, has a completely disjoint set of people who like that product, who have interacted with that product. So it's unlikely that somebody who likes this product will also like this one. This is super simple and a kind of straightforward way to think about it. And then you can define this measurement. So here I gave examples of the exact same set of people or a completely disjoint set of people. Obviously, in reality, those are mostly going to be a little bit more fuzzy. But you can define that distance using a metric called cosine similarity, which measures the distance between these two vectors. If you have these as vectors of zeros and ones, you can take the cosine similarity between them, and that gives a measure of how far apart those two vectors are. There are other more complicated things you can do here. You can take this matrix and do matrix factorization on it. You can use you can incorporate side information about the users or about the products. We have done some of those things in some places. There's a bunch of different versions of this that we use for slightly different purposes at the moment. But this is kind of the core idea and was one of the first recommendation products that we put together. So this is a little bit of what that pipeline looks like. So we start in Snowflake, this is where our data lives. This is our data warehouse. We're going to move into a Databricks notebook and build a user and item matrix in Spark, and then use the column similarities function in Spark to calculate the cosine similarity between different item vectors. And then we're going to do a big batch job and score all of these products. And then we're going to write out the top, 100 most similar products for each product to an RDS database. So we're going to use a Postgres RDS instance and write out this big table mapping products to most similar products. And the reason that we decided to do this in a relational database here was that we wanted to be able to also filter these results along certain axes. So we wanted to be able to include information like what product category it is. So these are, I want to look at only similar shirts, or I want to look at to only show dresses that are similar to this shirt, because these are all things that you might want to do depending on the particular interaction with the user that you're doing. So we wanted to be able to empower the product people to decide what sorts of filters make sense in their scenario. So we can include all of that side information in a relational database, and then have your API accept these kinds of filters and pull out the top products that are most useful in whatever given scenario. It's been really useful to us to kind of try and frame products in this way of building out capabilities as much as possible, and that are then used in multiple places around the org. So we have our Flask API, and then we also write results out to Snowflake in order to do analysis and monitoring and keep an eye on the process over time, right? So to look then at a little bit of what these products might look like once we actually get them integrated into places where the customer might see them. So this is an example of an email campaign that we run where when somebody's interacted with a particular product a lot, we can then send them an email that's like, hey, you looked at this product, maybe you like these other products that are similar. I mentioned that we do a bunch of different versions of this. Another version of this is instead of at a product level, we can do it at a retailer level. So maybe somebody has joined ShopRunner and they're new to ShopRunner, and so they don't know yet who all of our partners are. So we want to send them an email and say like, hey, we've seen that you really liked Neiman Marcus, but we want to let you know about other places in our network where you also might like to shop. And so you can use this API to quickly grab similar retailers to a particular one that we know somebody's interested in. So now I'm going to talk through another example, and this is a little bit more of a kind of data capability. So this is a little bit lower level than super product facing, but has enabled a lot of really cool products and improvements in a lot of the products that already exist under the hood. So basically, we wanted to be able to have a better kind of set of data about our users. So we have a whole bunch of data, but it wasn't very well organized. And one of the kind of ways in which it was difficult to organize is that there are a bunch of different identifiers for people. So there's a member ID, that's like the ShopRunner user ID, right? When you sign up for a ShopRunner membership, you get one. But when you're browsing on the web, that's not always attached, right? You don't have that information in the browser. So what you get instead is cookies. So we have our cookie here that you see attached to your web page as you're browsing on the web. So here we have a person who is browsing on a website one day and they're looking at several different products, and then they find one that they really like and they want to buy. And on the checkout page, there's an option to sign into ShopRunner and get your free 2-day shipping with that product. So they're like, yes, I want to get my free 2-day shipping, so I'm going to sign into my ShopRunner account and then make this purchase. So at this point, once you sign in on that day, you have an identifier attached to that session that says, this is this member. So we know that this member and this cookie belong to the same person. And then on another day, say you're browsing on a different website and on a different partner. And so again, we have a cookie attached, but you have a different cookie this day. And then same process. You look at a bunch of different products, you find one that you like, and you purchase it, you sign in, you get your member ID attached. And so now we know that this cookie also belongs to this person. But if we just take our data raw as it is in the system, currently the only things attached to this member are the 2 items that they purchased and the fact that they viewed those 2 items. But none of these other products that they looked at are attached to that member. And we want to be able to say that all of those views belong to the same person. So in order to do this, we use an identity graph. So here we gather those IDs from our event data. We build a graph linking between the IDs. And here we use Databricks and we use a library called graph frames. And then we find the connected components. So we find all of the IDs that belong to particular people. And then this graph feeds into our shopper profile pipeline, where we take these identity graphs, we take data from S3, we take data from Snowflake, we kind of organize this data into a reasonable way, we augment with some shopper level modeling using Spark ML, also on Databricks, and then we store all of this in a DynamoDB database, and also in Snowflake. And so this supports, the DynamoDB database supports a really quick access pattern for an API, and Snowflake supports our analytics pipelines. Last thing I'm going to talk about is a trending product. So for District, which is our mobile shopping app, we wanted an engaging, personalized feed as the kind of landing page on this website, on this app. And so for this, we wanted a way to identify products that were trending. So what we've done here is we've used a Spark job to kind of process all of the browsing data for all of our products over the previous week and then over the current week, and then identify these spikes. So we do some statistical stuff, which is always good fun, and identify which products are significantly more popular this week than they are last week. And so you get to see all sorts of fun stuff like this, like with this, like sports teams that have just won a big game are always trending, things like that. And then we use this both as a trending, this is an example of our mobile app with the trending feed going by there. And then we also can use it for partner websites as a widget that we like offer as a capability where they can pose things that are trending within their store. And then some other stuff we're working on just as little teasers. So we're working with visual similarity, with attribute labeling and taxonomy classification. So taking these product images and descriptions and using deep learning to classify where they belong in the taxonomy or what kind of attributes of that image are. We're doing some work on churn modeling and other fun stuff. So that gives you a taste of the types of things that we work on. And I'm going to hand it back to Tanya for some Q&A.
Thanks a lot, Hannah. We have been very busy in the Q&A box here. This was very interesting. Thanks a lot for giving us a peek behind the scenes actions. Now, let's get to the questions. How big are your pipeline clusters? How fast do you process your data?
So that's a question.
I believe that's for Hannah. Yeah.
Sure. So that's a question that varies a lot. We have a bunch of different pipelines that process things, different sizes of data at different speeds. I think the biggest cluster that I've run is in a job is 64 nodes. A lot of our really big batch job that processes all of our data might take 12 to 14 hours, but it's doing a lot of processing on a lot of data. And those don't run every night, obviously. So different jobs run on different cadences. So there's a lot of variability there. But that gives you some idea, maybe.
Thank you. One more. When you provide recommendations of other similar products, aren't you advertising for competitors?
So it depends where we do that. So we're careful about where we do what, right? So there are cases where we will advertise only within retailer. So there are like some emails that we send. If you've been looking at a product on Bloomingdale's, we will only recommend other Bloomingdale's products. There are other cases where retailers have agreed to be part of a group where they are okay if other people's products are recommended because they will also be recommended for other people's, if that makes sense. So it's all kind of negotiated with retailers how they want to play that out.
Got it. Thank you. They keep coming. Are there specific metrics ShopRunner uses to assess how good recommendations are, MRR or NDCG, or what are the metrics that you use?
Yeah, so this is a thorny problem, right? Evaluating recommendation engines is really hard. We've used a number of different offline metrics at different points. Some of them we've used some like ranking metrics sometimes. To be honest, like don't have one that I love. I've never really felt like I've been able to super accurately evaluate a recommender offline. I think really this is a case where you need to get it in front of people and you need to get user feedback. So we kind of took the approach of taking some offline metrics and making sure they didn't look completely garbage, and then keeping a really fast iteration cycle and getting it in front of users as quickly as possible, and then saying, okay, people interact more with this, so it's better.
Got it. Thank you. Well, let's give you a little bit of break, and a question for Brian. How does Delta Lake work with data provenance? Does it keep all of the data or only the changes in the data, like Unifies?
Yeah, great question. So Delta Lake sits on top of a data lake and manages the data in there with certain tables. And so you can definitely do the ability to see different versions, what we call time travel of your data. So you can go back and look at for any of these. So in the case of Hannah, if she wanted to go back and take a look at, well, Hannah, if any customer wanted to use this, and to see what was the data set yesterday that we were running for our recommendations, Delta would allow you to go back and do that. In terms of overall data governance, going back to sources of data and things like that, it's not going to offer that. So, how the data got into Delta Lake, where it came from, we typically partner for that further back governance. But it is interesting to note that when you put MLflow and Delta Lake together, you can track your machine learning algorithms, you can track how those process the data, and using Delta, you can track, which version of the data. So it gives you a very powerful ability to at least be able to audit your, machine learning processes.
Thank you, Brian. Could you please talk briefly about Databricks Unified Analytics Platform, MLflow, and SageMaker integration, please?
Yeah, so the SageMaker integration is very much part of the MLflow ability to put jobs into production. So you have a lot of different ways that you can do that. Hannah has depicted some of this in terms of what they're doing with Dynamo and being able to get data out and available to the website for fast recommendations. But that's the main flow of our integration with SageMaker. And the other thing is the training that I had mentioned earlier in my last slide also depicts some of the integration with SageMaker. So that's a great place to go and actually see that and learn more about it as well. You can actually see, what the technical aspects are of doing that integration.
Thank you, Brian. We'll get to one last question, maybe a couple, and please feel free to. We'll make sure that we follow up with everyone else that the questions that we didn't get to, and make sure that they get routed properly. Back to Hannah now, please. Are you processing 1 terabyte of data per retailer, and how often do you update or refresh the models?
Yeah, so I believe the terabyte number is not specific to a retailer, but rather across. Although it's also been a while since I pulled that number, so I don't know. It's probably a little bit larger today. On the refreshing point, it's again a thing that varies per model. So there are some models where the cadence is pretty quick, so the trending algorithm makes sense to refresh really frequently. So that happens at least once a day. The recommendations, some of the kind of more data intensive ones we refresh once a week because those change much more slowly, right? The interactions, we don't expect the distribution of interactions to vary wildly week to week because we're interested there not in changing day-to-day patterns, but in long-term kind of preferences. So you try to take into account kind of the cost, right? Like how expensive is it to train the thing and how much value you expect to get out of having it updated more frequently and balance those for particular use cases.
Got it. Thanks a lot. One more for you, please. When recommending products across different vendors, do you have any issue related to which of the vendors you prefer, show first, which you show last? How do you rank them? How do you handle this ranking problem?
Yeah, so it's not a thing that we've hit that much, to be honest. So it's going to be kind of use case specific logic depending on what makes sense in a particular scenario. That's both but kind of balancing what's best for the end user and what's best for our retail partners. And we just kind of always have that conversation.
Got it. One last geeky question, I can't help myself, and then we'll close. Comparing item vectors using cosine similarity in a naive way would be O of n square complexity. How do you pre-process items that you compare, and how do you streamline that? How do you handle that complexity?
Yeah, so we handle it different ways in a couple different places. So the kind of naive cosine similarity where you have these really sparse vectors. There's the method that I mentioned, the column similarities in Spark, implements an algorithm called dim sum that oh goodness, I don't remember who wrote it. Somebody, a particular company implemented it and contributed back to Spark that does a approximate nearest neighbors search, basically, in a particular way. There are other cases where you have shorter dense vectors, and in those cases we've used something like Annoy, which is a Python library that does an approximate nearest neighbor search. Basically, once you get to a certain scale, you need to do an approximate thing instead of a naive n-squared comparison. But there's a lot of good ways to do that.
Got it. Have you published any papers or blogs regarding the recommender systems that you have implemented, like this, a couple of libraries that you mentioned during, while answering this question?
I have not done anything specific about recommenders.
Okay.
Yeah.
Oh no, thank you. Maybe we can follow up later on. So thanks a lot. Thank you everyone for attending today's webinar. Please remember to stay connected and complete the brief survey at the conclusion of this webinar. We look forward to supporting you in current and future projects. I would especially like to thank Brian and Hannah for taking out the time and giving us this amazing deep dive. If questions are any measure of how this went, it's been one of the best ones. Thank you again, everyone, and have a great day.